All right, good morning, everybody. This is Jason Caldwell at the Sanborn Map Company. Today, we're going to present about three-dimensional building modeling. And I wanted to just do a quick introduction to the presenters. I think I know most of you in the crowd here. I've been working with Sanborn for 22 years and have lived in Colorado most of my life. I always like telling people that I've lived here long enough where they've turned my elementary school into a brewery. So with this said, I want to introduce my cohort here. Srini, if you'd like to give a quick review of your experience.
Hey, good morning. I'm SriniDhar. I'm from Pittsburgh, Pennsylvania. I've been with the geomatics field for 30 plus years, primarily working in the areas of photogrammetric LiDAR and other related areas.
All right, thanks so much, Srini. We'll jump right into the presentation. I thought I'd give a quick overview of Sanborn, and then we'll talk about some technical details associated with three-dimensional modeling. So Sanborn's been in the business for quite some time. We've started mapping in 1866. And since that time, we've evolved in terms of the capabilities of our mapping technology and did digital orthophotography, digital aerial mapping since 1966 timeframe, and started doing LiDAR mapping in 1999. And a lot of that type of work included different levels of three-dimensional modeling. So lots of experience there. And in terms of a company overview, Sanborn likes to look at our business model as a pyramid, and the base of that pyramid starts with high quality data and map production. So, ortho imagery, LiDAR, metrics, things of that nature. And as you go up this pyramid, there's additional value, right? Extracting intelligence out of the information is that value-added service component. Developing software applications for distributing data to clients is another step up. And then visualization systems, which has a lot to do with what we're going to talk about today, which is 3D modeling, is the next step up. And then the final step is the decision support system, where we're providing answers to the business questions. So that's how Sanborn looks at it. We provide services in all components of this pyramid, but it all starts with high quality mapping services as the base of that pyramid. We own most of our own assets. We own aircraft. We own multiple different types of sensor systems to collect three-dimensional data, both for internal and external type of structures. We own our own IT infrastructure. And so, Sanborn is basically an end-to-end solution in terms of data collection all the way through data processing and delivery to our customers. In terms of qualifications, Sanborn's been working in the state of Colorado for many years. We have over 200,000 square miles of mapping that we've completed over the last 10 years within the state. And we've done quite a bit of work for this region. We, for the last 6 years, have completed the imagery program, the DRAP program for DRCOG. We've also done the same thing for the Pikes Peak Geospatial Alliance. Recently, we've also worked with the USGS as well as the Denver region to collect LiDAR for well over 20,000 square miles. We've done quite a bit of work for Denver Water, City and County Denver, as well as Forest Service, NRCS, USDA, and some other smaller towns within the state. So quite a bit of experience here. We're always happy to present and address in the Rockies because it always gives us a good opportunity to see friends and family from the industry. So today we're going to talk about 3D, and as a baseline, we want to give you kind of a little bit of background of our experience within the 3D environment. We have over 20 years of building 3D models. We originally started building 3D models for the central business districts across the United States. We have over 65 cities that we've developed those products under, as well as 13 international cities. Typically, it all starts with data collection, and that includes imagery, vertical and oblique, as well as LiDAR, to be able to extract out the information that our clients are looking for. So the current situation has been interesting. I would say over the last couple of years, we've seen a little bit of an evolution in terms of 3D. The biggest thing I would mention is that through some levels of automation that Sanborn has developed, the cost has actually continued to come down while the quality has gone up, which is exciting. The other piece that's pretty exciting is the fact that the industry as a whole, from a software perspective, is starting to allow for more integration of these 3D types of products. So Those two items combined really open the door for more use cases and people with lower budgets to be able to afford these higher quality products. So that's really exciting news. The other thing that's changing a little bit right now is the fact that people are starting to get interested in more than just the exterior environment. They also want three-dimensional modeling completed for the interior of their building. So we're going to talk about most of those items today as we walk through this presentation. With that, I'm going to hand it over to Srini for him to talk about the details of our three-dimensional models.
Thank you, Jason. So the next few slides, we talk about the 3D building model creation, the process, the various processes that are involved, the data inputs that goes into the 3D building model creation process, those type of things we will talk in the next few slides. Before that, we want to talk about the level of detail. In the architectural world, the 3D building models can be categorized into 5 different categories, starting from LOD 0, that is level of detail 0, to level of detail 4. The LOD 0 is primarily a 2D footprint with no elevation or no Z value. The LOD 1 is primarily an extruded building, and LOD 2 is an extruded building with the roof types. And LOD 3 is full architectural features, including doors, windows, etc. And LOD 4 is purely interior modeling. So what you are seeing, the picture, or the various examples, or the LOD 0 to LOD 4, we will talk more in detail in the subsequent slides. So whatever be the product, whether it is starting from LOD 0 to LOD 4, there are 2 important aspects that needs to be considered. One is the geometry, the other one is the texture. So geometry means it's primarily the shape, and texture is something that gives you the visual perception in a 3D model. Now, as Jason mentioned, there are various geospatial data Sanborn collects, primarily LiDAR, predominantly aerial LiDAR, as well as a static LiDAR inside the building. As well as the imagery is concerned, it can be either a vertical imagery or it can be an oblique imagery. So the geospatial data can come from any form. It can be a LiDAR imagery or a combination of both. But what we do in the processing is we address both the geometry and texture separately. So as I said, the geometry is primarily the shape, and the texture is, is primarily the visual perception. So in this slide, what you are seeing on the right-hand side is a picture showing how the oblique imagery is taken. This gives you that a given feature or a given building is seen through 4 different angles. So as I said, you can capture the geometry either from LiDAR or from stereo imagery or from oblique imagery. Each one has got its own advantage as well as disadvantage. In the case of aerial LiDAR, the buildings can be captured in a more automated manner, which means it is less time consuming and less cost, but it lacks the detail. As well as the stereo imagery is concerned, I think it is highly accurate and detailed, but it is very labor intensive, which means it is going to take more time and more cost. Whereas the oblique imagery, it provides you an high accuracy as well as the detail, but it is less labor intensive. We will talk in the later section some of the building models that has been created using the oblique imagery. So here is, we go one by one with regard to the level of detail. LOD 0, as I said, there is no Z value, there is no elevation, and it is a standard 2D building footprint. It is created from an ortho imagery. There is no Z value. Whereas LOD 1 is primarily created with a one single elevation value. Primarily the highest point on the building is captured. We call them as a 2.5D dimension, LOD 1. It is primarily a sugar cube, and whatever the figures you are seeing on the bottom, the one which you are seeing on the left and the right, primarily with no texture. And what you are seeing on the left is an example of LOD 0. That means there is no Z value. Whereas what you are seeing on the right-hand side is primarily LOD 1 with the highest point on the building is captured with no texture. Next slide, please. Okay. The LOD 2 the pictures in this slide shows you the LOD2 as well as the LOD3. What is on the top is the LOD2 and what is at the bottom is the LOD3. As I said earlier, LOD2 is primarily the extruded building with roof type. So we go one step further from LOD1 in the sense we don't capture a single highest point on the building, but primarily we capture the entire roof type. And whereas in LOD3, we go one step further, not only the roof type, but also we bring all the architectural features, including doors, windows, etc. Next one. The LOD4 is another step, where we go inside the building. So, that way you can create a sort of, building interior features, and that will be used for a 3D interior building model. So what you are seeing on the right-hand side, the video is primarily the conference room of the Buckley Air Force Center conference room that has been captured using the interior LiDAR scanner that I will talk about in the next slide. And primarily the interior mapping can be, the data source can be from various things. It can be a CAD building plans, or it can be a digital blueprints, or it can be a hand modeling, or it can be a LiDAR scanning. So what you're seeing at the bottom is a two-dimensional floor plan that can be converted into a 3D interior modeling. Next one. So this is a slide, I think, to show you both wherein we have created the exterior 3D model as well as the interior 3D model. And what you are seeing, this interior building is primarily our office at Colorado Springs, our corporate office. And the entire building has been captured using our own in-house technology, what we call them as a spin. It's primarily an autonomous LiDAR sensor that goes inside the building and collects each and every corner of the building. And what we have done is we have taken the interior information from our spin technology and the exterior building model from the other sources, what we have described. And then we combine them, both the exterior as well as the interior. One of the important thing here is each and every feature asset within the building can be tagged. And that way you can do a sort of asset monitoring can be done. So we talked about the geometry. Let us go into the texture. One thing I need to tell you is the geometry is a must, whereas the texture is maybe there, may not be there. But as I said, the texture gives you the visual perception. There are various sources from which we can get the texture. It can be orthorectified imagery, oblique imagery, geophotos, and texture library. We will talk about the geophotos in the subsequent slides. And obviously, the question will be which source we have to use. That depends on various parameters, the collection methods, the cost, the most important thing, the resolution, as well as the visual quality. So these are all the parameters will determine which one we need to use. So as far as the texture is concerned, Sanborn has come up with its own method using the GPS-enabled photos. We call them as a geo-feature modeling. What you are seeing on the picture is, on the right-hand side, is a building is being captured from the GPS-enabled camera from different angles. The angles, needs to be, determined depending upon the buildings that we capture. Here I need to say, add one more thing. Most of the buildings we can get from the oblique imagery itself, but in some cases, a few of the buildings we may have to go to the ground, and then we have to capture using the GPS-enabled cameras as shown in this slide. Next one. So in this case, we talk about the geo-feature modeling, a process that we have developed. What you are seeing on the left-hand side on the bottom is a photorealistic thing. And what we are doing on the right-hand side is we take the photorealistic picture and create something, a visually aesthetic model. And that process, we call it as a geo-feature modeling. So what you are seeing on the left-hand side picture is primarily you are taking the same building from different positions using the same camera. You will see a seam line. There are some shadows will be there. So there will be some sort of adjustments needs to be done. And in order to make sure that we adjust the radiometry, we take care of the seams and other things. And that process, we call that as a geo-feature modeling. And that is what you are seeing on the right-hand side is a clean, seamless building picture with a texture. Next one. So So when I talk about the texture, there are two different things are there. One is, you can create the texture just like explained earlier. You can take from the oblique imagery or from the ground-based imagery. But nowadays, the texture, computer generated texture is available in the form of a texture library. And you can either go through your own method, create the texture from oblique or from the ground-based cameras, or you can pull the texture readily available from a texture library. What you are seeing right now is a computer generated texture, and in the next slide we will see a photorealistic texture. And in this case, what has happened is both the oblique imagery as well as in some cases the ground-based camera has been used to create the texture, and whereas the rooftop texture has come from the ortho imagery. So basically we have combined both the ortho imagery for the roofs and all. As far as the sides are concerned, we have used the oblique imagery and created a photorealistic texture. And one more important thing here is that at this time, it is each and every building can be attributed, and that way I think you can enhance the value of the product further. Next one. At this time, with that 3D building models are created, how the building models can be updated and maintenance, and what are the use cases will be covered by Jason.
All right, thank you so much, Srini. Yeah, so Srini's mentioned, a lot of clients do have interest in understanding how they can maintain their three-dimensional models without having to do a full build up every time. Obviously, this keeps costs low. And so we've developed a production process that allows us to edit both the geometry as well as the textures, as well as removing or adding objects. So this allows for an update to the actual building model itself. But the second component that allows for is if we do have clients that are interested in actually seeing what a building would look like prior to it actually being built, you can actually add in features to the three-dimensional model to allow for a visualization perspective that you wouldn't get otherwise. So the nice thing about the updated maintenance is the fact that you don't have to necessarily rebuild it every time. You can go in and actually correct or make the changes that are necessary at a given date. The other big thing that I mentioned early on in this presentation is the value proposition associated with data integration, which is a pretty important aspect for the use of this data. Over the years, what we've seen is that people really like data visualization tools. It's exactly what we see in the real world. It allows us as GIS and mappers in the profession to explain to our end users that are not GIS and mapper professionals what we're looking at. When they're looking at it in 2D, it's a little bit harder for them to understand in comparison to 3D. So, we know the quality in the visualization products are exciting to use, but over the last 20 years, what we've seen is there's been a little bit of a struggle to match the use cases with the ROI and budgets, right? So the data integration component I see as a very important aspect of what it is that we're able to do with 3D now. And so to be able to integrate this information with a wide range of other types of data sets allows us to do our analysis while still using a 3D base map. So, if we're talking about assessment, if we're talking about emergency response, resource management, real estate, anything of that nature can be overlaid within the 3D so that we can actually get the answers we want while still seeing the visualization aspects that we have. As an example of this, we actually took the three-dimensional model that we've recently created within the Denver region and actually imported that into ArcGIS Pro. And so what you're seeing here is our model directly imported into ArcGIS Pro, overlaid with some of the city and county GIS layers. In this case, you're seeing the street layers that are overlaid with the 3D data. And the next thing here you're going to see is the tree inventory that the city and county in Denver maintains, overlaid with this data set. The reason why this is relatively important is that this data set is 3D, which allows you to do some updating to some of your existing data sets. For example, you could go in and actually capture the trees that have been removed and remove those points, or you can go in and actually add trees that have either grown in terms of height or been modified. So it's pretty exciting to see, Esri, for example, have the capability to be able to offer this type of integration. I mean, we're all using Esri for the most part. And so to be able to actually have a base map that gives us the visualization capabilities is exciting from an integration perspective. So when we think about use cases for 3D, this is the important component. This is where we're getting the ROI. And really, there's multiple markets that we see as providing pretty significant value in the use of 3D. That includes emergency response and law enforcement, situational awareness, real estate management, tax compliance, assessment, zoning type of components, as well as building approval and impacts. Training and simulation is another aspect when you think about AR and pre-planning. So the next couple slides here kind of talk a little bit about that. Urban planning and management. One example here is line of sight associated with telecommunications between buildings. Construction permitting, another example here where apartment complex is being renovated and the status is being tracked. Down on the left-hand corner, this is an example of essentially a command and control operation type of platform. And then there's always cultural heritage where we're looking at historical changes between two dates and be able to visualize that in 3D. So looking at a couple of those examples, here's one that we always like showing because it does a pretty good job expressing what we're looking at here. Within this application, we have the 3D base map, but we also have a connectivity to multiple assets that have automatic vehicle location information tracking on them. So those assets are being tracked, and then from different positions on different structures, we're able to identify where we have clean line of sight versus where we don't. This is an example where you may have like a VIP, like let's say a president or a mayor that's coming through, and you want to make sure from a security perspective that the area is secured within the dome that we have there. So just one example of how it can be used. Another example, Srini talked a little bit about the indoor mapping in combination with exterior mapping. This is becoming more and more important, especially if you're familiar with building information modeling or BIM modeling. So being able to essentially tie all your assets within a specific building and be able to visualize that in 3D, both on the exterior as well as the interior of the building, is an important aspect, right? So being able to lower construction costs, lower maintenance costs, as well as essentially use your resources better is really the idea here. This is getting close to what we would consider a digital twin type of product, and being able to offer our clients a solution where each individual structure has all kinds of information associated with it that you can visualize as well as attach to databases and be able to get the benefit out of it that way. So really, to end this presentation, it's a discussion about how the visualization products have gotten better over the years. We've been able to not only do visualization on the exterior, but also on the interior of structures. And because the costs are coming down and we're getting greater integration, we now have the capability of doing all kinds of different integrations associated with real-time information like AVLs I was just showing, being able to view this information from smartphones and tablets and not just within a Power GIS software, and being able to integrate this with VR and AR are all aspects of the way that we can use this type of data set. So really, the end point here is that we see business models evolving to allow for three-dimensional database integration with 3D data sets to allow for more use cases and more ROI. So with costs coming down, with the visualization products getting better, and with more integration, what we see is that ROI continues to rise, which is exciting time for three-dimensional modeling. So with that said, I'll thank you for listening to the presentation. And if you have any questions, feel free to ask now or send an email to myself or Srini. So thank you.